Hello friend, welcome to my YouTube channel Virag Automation. Today we are going to learn how to calculate pump motor size by using Microsoft Excel tool. In this tool we are just putting basic information and get the required motor and pump size. Okay, now I am going to open my Excel tool. Now in this video you can see the Excel tool. In this Excel tool there is a two tables you can see. First in my left hand side and second one in my right hand side. I will explain one by one. I'm starting from this left hand side. In this left hand side table now you can see the pump details, the basic information they are asking, like that key suction head, discharge head, and all the input diameter of pump, output diameter of the pump, all the basic information is there you can see. And in my right hand side you can see that directly we are putting pump details and get the required motor size in horsepower. And in the bottom side you can see there one liquid name is there, and then their temperature and their density you can see here. Because in the basic information this left hand side table now we required this density and the temperature, all this basic information we required. That's why for your help we are putting all the whatever the basic information we can collect now, we can require during the calculation of pump motor size. We are giving in this single Excel table, Excel tool, you can see that. I'm starting with this left hand side, and in my first in row you can see static suction head. It means we are representing with the h1 is the constant parameter, and you can see the value in meter only. We are like that key the suction head, always the suction head is the minimum value. I think the suction head should be minimum only, like that we are putting here one values. I'm using only just basic information, and this maybe some value is not in practically not possible, because I'm just only for study purpose we are giving directly all the values. And whenever you are designing now, though, you can put the whatever the practical, whatever the practical possible values now you can put only here. Now I'm starting here. My section head I'm putting one only because it should be minimum only. And then discharge head, like that we want 20 meters discharge head, so that's why I'm putting here 20. Now my third row is there, is pump inlet diameter equal to outlet diameter. Okay, I'm putting here no, it is not there only. So we can choose both both this one, yes also we can put here, and no also we can put here. I'm here only putting no. Okay, enter pump inlet diameter. So you can put pump inlet diameter, like that key whatever the pump inlet what is the diameter I'm putting key. He is showing in 1 meter na, so that's why I'm putting here point 0.127. And then outlet diameter also I'm putting same here. The density of the liquid, like that you can see that in this table the density I'm putting here, like that 1010 only here na. So I'm putting this value for the beer only, and then the temperature is 10, like that whatever the density of the liquid is available in this table, and then temperature and then liquid. I'm putting here 1000 density, the required amount of liquid at the particularly head, particularly height, like that flow they are asking. I think whatever the basic information is that we required one height, we required a second thing is my flow, third thing all the key whatever the my pipeline size, all these thing we are just my basic information. Here I'm putting liters in this height in liquid. Now we want how much amount of liquid, I think 900 liter I'm putting here only. And then getting the liquid in the particularly height. Time I'm putting here, time I think 1 minute na, liter per minute I'm putting here, so 900 liter per minute I'm putting here. So you can change liter to meter cube only here, and then you can put say here second also. So I'm just putting both these values in liter and minute only. And then you can see here only whatever the information we can't add, actually they calculate by using this table. I'm putting this tables, rows, cells na, they are, we are only just drawing na. Here you can give na input data only, and other datas we can't change. This value is only calculated value only, and this calculation is based on the input data whatever we are putting in this row only, in this cell only. So this as a flow rate, q is the value is there, cubic meter per second. This is the calculation is coming. Input velocity, output velocity is coming here only, and then head inlet and then the head outlet is coming here only, and the difference in the head is 0 meter and total head is 21 meter. 21 meter is the total head, because 20 meter is the discharge head and 1 meter is the static section head only. And here in this you know that key, whatever the liquid is going to one place to other place na, the whatever the medium is there, here friction loss is happen in the pipe. Maybe any type of medium is there, the friction loss is happened. That's why I am putting here some journal. I'm just putting here only assumption only, like that I'm putting here 30%. And then maybe this value vary from 10 to 20, 10 to 30, 40. You can put it here, no issue. Then after putting this 30 value, you can find out the actual total head, because friction losses and all these things. Now my head is coming 27. If I am putting this value 20, so then the value is coming 25 meter only. And then pump hydraulic power. Whenever head is come, my flow is come, then basically the pump horsepower is coming. Then pump horsepower and the pump efficiency I'm putting here, because in mechanically whatever the mechanical equipment they are giving only maximum 90%. The efficiency is only between 80 to 90. That's why I'm putting here 80. You can also put here 90 also. I'm putting here 90%. Then the motor and the pump shaft, then this value is 4 kilowatt. It means is coming here, and the motor efficiency is also 90%. And then you can I'm just change this value, because mechanically thing is there na, so that's the mechanical equipment is there, so that's why the efficiency is not um, go higher, only 80 to 85 something is there. Then motor efficiency is 90%. And then a safety margin as per American Institute. Okay, this I'm putting here one is a safety margin. One, it means not one only, because I'm using 25%. Always we are putting safety margin, so that's why 4 is the total value and 1 is 25%. Then 5 kilowatt motor is there. The required motor size is coming after whatever the value we are putting here now. Then the kilowatt size is 5 kilowatt and the horsepower is 7 HP only. If I am changing my head like that, I am putting here 25 something, so then you can see my motor size is increasing. If I am putting value my discharge head I am putting 15 only, then you can see my motor size is decreased by 1 kilowatt, and now value is coming 4 kilowatt, and the HP is 5 HP only. Now in this same videos, in this left hand side in video, you can see the table. I am putting here only the basic information, discharge, head and flow, all these things. We can also this is also happen, because if we know the pump details and all these things like that, suction pressure, discharge pressure, then the volumetric flow you can know, and specific gravity you can know, and then gravity of the flood you can know. Then you can put it the value here only, and then pump efficiency only, and you get the all the details related with them, like that. Differential pressure, if you are putting the value in this cell, what I'm showing here in this video, you can see this is the input values is here only. You are putting value in this cell, you get it the value in this calculation bar only. Now I'm safety margin you can also add, like that. Safety margin always 1.25 only, so you can get the final required motor size in kilowatt also and HP also. Just you don't relate both the table is same only, because this is the basic information is required to calculate the pump and motor size. In this, the pump detail is required to calculate the motor size. So if you know, you want to get the this density and temperature detail of the particular liquid, you can go this, you can follow this table. In this table you can see acetic acid and all this ammonia, butane, chloride, kerosene, all these type of liquid, whatever the available, whatever the possible na, I will put it here only. And then their temperature in degree centigrade, Fahrenheit, and all these values, and I'm putting the density also, whatever the possibly standard values now available in kg per meter cube, I will put it here. So you can get easily the motor and pump size. So I hope you can understand and understand this excel tool, how to operate, and how to get the required motor size, required pump size. So thank you very much to see this video.